So actually, this presentation was a webinar. Not sure that you were in this day. I think you didn't. I mean, it was for another group. We transmit for different countries. So there are two main things here. One is the transition for renewable energies in mining. What is happening? The case of Chile. That is because there are some agreements, but in general, most of the things are going to renewable energy. I'm talking about solar and wind energy, and we are fulfilling this very well. In terms of combustion engine machine, this is more difficult. There are technology. In another presentation, we also have another study case when we replace some of the fuel for these big mining trucks. But let's say mining trucks, machinery in general, is not going in the direction of doing changes. I mean, the vendors, they're not really changing the motor. Perhaps you don't know, but those big trucks are electrical trucks, but they have a generator inside the truck. So they consume fuel. Okay. There are some projects with hydrogen, didn't work well, but my feeling is that the vendors, they are not willing to take technology in that direction. The rest of the plant, yes, of course. There are some plants like Sierra Gorda in Chile with 100% renewable. It means they have a contract 100% renewable. And to be clear, there is no way to know if one electron is coming from solar energy, wind energy, or fuel, because in our system we have all of them interconnected. You know what I mean? Methane, thermal plants, wind, solar, all of them interconnected. But this company is paying a contract with only renewables, so it is cheaper. Some days you have 100% renewable in the whole area of Antofagasta because of it. But some days you don't. So they can claim 100% renewable, but it cannot be, let's say, audited. You know what I mean? But they have the contract. So what is the situation? What is the situation? Most of the companies are committed to reduce CO2. So, as you know, the energy consumption in mining operation, the higher consumption is comminution. You're talking about big equipments. A SAG mill has a power. Let's say a SAG mill. How much energy does a SAG mill, regular SAG mill, consume? A number. Kilowatt, megawatts. Number. 12, 15. How many kilowatts? Sorry, how many horsepower? It can be HP, it can be 12 HP times 3/4 would be kilowatts. You need to have the both conversions. HP to HP, 1 HP horsepower, it would be 3/4 kilowatt. So we have the first SAG mill in the world was installed in El Teniente in Chile. This SAG mill was about 15,000 horsepower, 8 meters in diameter. It was the first one in the world, SAG mill. So, short answer here: how close is hydrogen technology? Very far, because the hydrogen production from fuels, I mean methane or hydrocarbons, is $1.1, $1.2 a kilo. This is today 90% of the hydrogen. The production $5. There are some applications. They are in Portugal, by the way, developing some technology to reach 3.5. So whatever thing we do to make profitable the business should be around 1.5. So we are far from that. So the short answer, we are really far from a green hydrogen. Whatever conference, whatever thing they say, we are really far. And we will see the numbers here. Okay. Well, this is the case of Chile. You know, most of the operations, they use very big trucks. They are big powering capability installed with solar panels. But there are not big trucks made of battery. This is a model. This is for, let's say, we are environmentally friendly. It's a battery operated with hydrogen. Hydrogen, it's used with oxygen for it's used in a fuel cell. You also can use hydrogen directly in the combustion machine. But most applications of hydrogen are going to be used in terms of fuel cell and electricity. Okay, so Japan decided to have only hydrogen-driven cars. That means fuel cell. America is using lithium battery-based cars, and there is something in between. With the car that you have, efficiency. So Elon Musk